Okay, in class today we're talking about angles and reference angles. Where it says radians, but we're not going to do it in radians. We're really only going to talk about degrees today. So remember, a degree is defined as being 1/360th of a circle. Okay, so some things to know. We always start with the initial side along the positive x-axis. That is your 0 degree mark, the positive x-axis. And we move counterclockwise if we have a positive angle. Okay, so think about having your arm pointing straight out, and as you move your arm vertically into the sky, that is making a positive angle. Okay, so this is 0 degrees. That means our next positive y-axis is 90 degrees, which means your next negative x-axis is 180 degrees. And then down to the negative y-axis, which would be 270, all the way around to our positive x-axis, which would be 360 degrees again. Okay, so a 360-degree angle means that you end looking the exact same direction as you started. Okay, it's really hard to determine whether it's a 0-degree angle or a 360-degree angle, unless you know that you did one rotation. Okay? So the other thing we're going to do is a reference angle. So the reference angle is sometimes called alpha, okay, as opposed to theta. The reference angle is the angle that you would make with your positive x-axis. Okay, what do you need to do to get back to the positive x-axis? So if we had a first-degree angle, okay, which would look something like this, where this is your theta. In that case, the angle of reference is the same as your given angle. Okay, your reference angle, or alpha, is going to be the same as your given angle. It is a first quadrant thing. Okay? Now, as we move around your circle, and maybe we do a 100-degree angle, okay, and hopefully you know that 100 degrees is a little bit more than 90. Right, so here is my starting reference side, that's 0, and then I would come up to about 100 degrees. Okay, if this is my 100-degree angle, then the reference angle in this case is the one that takes us back to the x-axis. Okay, this is going to be your alpha, or your reference angle. It's the angle formed with your x-axis. So if I had a 100-degree angle, then my reference angle is going to be 180 minus 100, which would be 80 degrees. Okay, so the reference angle is the angle that you need to get back to the x-axis. So in the first quadrant, the angle is the same as your given. In the second quadrant, you have to subtract your given angle from 180. Okay, if per se we had a third quadrant angle, something like, I don't know, 210 degrees maybe, right? So if this is a 210-degree angle, then how far past 180 have I gone? Right, so your alpha, or your reference angle, is what it takes to get back to the x-axis. And you always want to go the shortest distance possible. Okay, so in this case, that would be our 210 degrees minus 180, which would make a 30-degree reference angle. So the reference angle is what it takes to get back to the x-axis in the shortest distance possible. So your reference angle should always be less than or equal to 90 degrees. It's always going to be an acute angle. Okay, maybe we have a 4th-degree angle right over here somewhere. Let's say this is 310 degrees. Okay, so we start at the positive x-axis and it goes all the way around 310 degrees. So in this case, if we have a 4th-degree angle, our alpha, or our reference angle, is what it takes to get all the way to the end. In other words, 360 minus 310. So our alpha, or your reference angle, would be 50 degrees. if we had a normal angle of 310. So the reference angle is the angle that you need, the degree angle that you need to get to the positive x-axis or the negative x-axis if you're in the second and the third quadrants. Okay, so let's get back to our drawings. Our first example says draw a 100-degree angle. Okay, so hopefully you do this. You start with your first angle at the origin and you draw to the right. Okay, so our angles need to have two parts. They have the initial side, okay, which is always going to be along the positive x-axis. And then it has your terminating side. So this is your initial side. And then it has your terminating side, which what actually makes your angle. So 100 degrees is more than 90, but less than 180. So this is your terminal side right here. And we have drawn a 100-degree angle. So then the second question, what is our reference angle? What is how much degrees do we need to add to 100 to get to 180? And that would be 80 degrees, or 180 minus 100. Okay, moving on. 315. So remember, 270 is straight down. So we start with our positive x-axis, initial side, and we go counterclockwise. So 90 is there, 180, 270 is down here, 315 is going to be somewhere down here in the fourth quadrant. Okay, that would be a 315-degree angle, which means our reference angle, to get back to your x-axis, would be 360 minus 315, which would be 45 degrees. Okay, so we're going to continue doing that for this entire page, drawing our angle and finding our reference angle. So we're going to do 195 and 490 and 820. So a 195-degree angle would have a 15-degree reference angle. Now what about 490? So we only have 360 degrees in a circle, which means we must have gone around our thing more than once, right? 90, 180, 270, 360. So how much farther than 360 have we gone? That is 130 degrees, which means we're going to end up over here in the second quadrant again. Okay, so a 490-degree angle looks the exact same as a 130-degree angle would. Okay, they look the same. If we didn't make your little curly Q down here at the origin, right, we wouldn't know that you've gone around the circle more than once. Okay, so these are called coterminal angles. So 490 degrees and 130 degrees are coterminal angles because they are 360 degrees apart. So if I had a 490, aka 130, how much do I have to add to get to my x-axis? So 180 minus 130 is 50 degrees. So if you can write it in terms of a 360 circle, okay, subtract 360 from your angle, then we're going to be able to find the reference angle pretty easily. Now 820. So this is going to take some counting. I hope you know all of your multiples of 360. I guess we're going to find out. So all the way around is 360 degrees. That's one turn. 2 turns is 360 plus 360, which is 720. So how many more degrees past 720 do I have to go to get to 820? Well, that's 100 degrees. And we had a 100-degree angle in our first example. So there is our 820 degree angle. So 820 would look an awful lot like 100. Those would be coterminal angles. 800 degrees and 100 degrees are coterminal angles. Sorry, 820 and 100. And that's going to help us figure out what our reference angle is. If we had a 100 degree angle, we have to subtract it from 180 to find a reference angle of 80 degrees. So if we have something more than 360, you're going to have to figure out how many revolutions have you done around your origin in order to find what your reference angle is. Okay? So these next ones are negative angles. Negative angles move clockwise around an imaginary circle from the positive x-axis. Okay, so a negative moves positive. So if you put your arm straight out and then you move your arm towards your body, right, down towards the ground, you're going in a negative angular direction. So if I had negative 35 degrees, we start at the positive x-axis at 0, and we come down 35 degrees, and that is a negative 35 degree angle. Okay, which would be in a coterminal angle, right, to the what one as a positive. So if you subtract 360 from 35, we get 325. So a positive 325 and a negative 35 degree angles would be coterminal, right? They would look the exact same. If you didn't have your arrow telling you what direction you went in, you wouldn't be able to tell the difference. But the reference angle is still the one that gets us back to the x-axis. So in this case, it is going to be also 35 degrees. Okay, negative 260. We start at the positive x-axis and we go in a negative direction. So negative 90 is at the bottom of your y-axis, and then negative 180 is the negative x-axis. Negative 270 is too far, so our angle is going to stop there, 10 degrees shy of the positive y-axis. Okay, so we could say that a negative 260 degree and a 100 degree angle would be coterminal, because they have the same ending angle. But the reference angle is still what gets us back to your axis. And in this case, that would be, once again, 80 degrees, because we have gone 80 degrees past 180 in a negative way. But your reference angles are always positive and acute. A negative 700. I believe we said 720 was 2 complete revolutions. So our negative 700 degrees is going to be slightly less than 2 full times around. Something like that. Okay, so make sure you have 2 parts. You have your initial part and you have your terminal side. Are the 2 parts that make up an angle, right? 2 rays from geometry. So our reference angle is what gets us back to the x-axis. In this case, we are 20 degrees shy of going all the way around twice. So we have a 20 degree reference angle. And lastly, negative 101 degrees. Once again, we have negative 90, so it's going to be down here in the 3rd quadrant. Negative 101. So we would have to add 79 degrees in order to get to 180. Or we would add 180 to negative 101 and get 79. Okay, so positive angles are counterclockwise around your origin, and negative angles are clockwise around your origin, where the positive x-axis is your 0 and your initial side. Okay, hopefully this helps you with your angle drawings.